Hello everyone. Today we are going to explore the type of superconductors. Today, we'll cover three key topics to explain the concepts of Type 1 and Type 2 superconductors. First, we'll classify the types of superconductors using two key parameters. Next, we'll discuss how Type 1 and Type 2 superconductors are defined, including examples of each types. Lastly, we'll explain about differences of electric behavior of them. As we learned in the previous chapter, the internal characteristics of superconductors define crucial parameters: penetration depth related to the magnetic field and coherence length related to the density of superelectron. The classification of superconductor types is based on these two important parameters. Type 1 and Type 2 superconductors are differentiated by comparing their penetration depth and coherence length. Type 1 have a relatively short penetration depth, which prevents external magnetic fields from entering the superconducting region. However, Type 2 have a relatively long penetration depth. This allows magnetic fields to penetrate into the superconducting region, leading to a unique state known as the mixed state. We will explore this special state further in Chapter 1.1.7. Here is a table summarizing examples of Type 1 and Type 2 superconductor materials. Type 1 superconductors are typically pure elements. On the other hand, Type 2 superconductors are generally composed of compound. The values shown in this table may differ from the actual values, because they use generally known figures. However, in general, we can see that Type 1 have a relatively longer coherence length, and Type 2 have a relatively longer penetration depth. Next, we'll discuss the electrical behavior of Type 1 and Type 2 superconductors. Type 1 superconductors are capable of carrying both DC and AC currents without any resistance, showcasing their ideal superconducting properties. However, Type 2 superconductors exhibit a unique AC losses. These losses are significant because they affect the efficiency and performance of Type 2 superconductors in various applications. In summary, the classification of Type 1 and Type 2 superconductors is defined by two key length parameters. Type 1 superconductors are relatively longer in coherence length, and Type 2 superconductors are relatively longer in penetration depth. Understanding this concept is crucial for advancing our background information about the superconducting materials in various technological fields.